Today we are going to talk about simplifying expressions by combining like terms. To review, terms are the parts of algebraic expressions that are separated by plus or minus signs. Okay, so terms are the separate individual parts of an expression. So if I have 3x plus 5, this is one term. And this is my second term. So this has two terms. Like terms are terms that contain the same variable raised to the same power. So for example, if I have 3x and 5x, they have the same variable, so they are like terms. However, if I had 3x and 5x squared, because of that squared, those are not like terms. Additionally, if I had a different variable here, they would not be like terms as well. When we see the phrase simplify expressions, that means that we're going to write an expression with the lowest amount of terms possible. So we want as few terms as we can. So we combine the ones that are alike to make our expression be as short as possible. Let's go ahead and look at a couple of examples to begin. First of all, if we see a variable that does not have a coefficient, we know that 1 is automatically in front of that variable. Now, you do not need to fill in that 1 if that is knowledge to you that just comes. But if it's something that you forget, I do recommend writing in those 1s. Now, the difference here is that we have y plus y plus y plus y. So our y's are being added here. Whereas here, they're being multiplied. So this is a quick review. When we add numbers together, repeated addition, that is multiplication. So I can take those. So if I just have 1 plus 1 plus 1 plus 1, I could instead simplify that to say 1 4 times. So here I can simplify that by saying 4 times y, which then shrinks down to just 4y. When we have a number and a letter next to each other with no operation in between, it is automatically multiplication. This is the simplified version of this. This is also the simplified version of this. When we add repeatedly, that is multiplication. However, when we multiply repeatedly, that is like this. Let's say, 1 times 1 times 1 times 1. That is 1 to the power of 4. So here with our variables, that will be y to the power of 4. So when we have repeated addition, that simplifies into multiplication. But when we have repeated multiplication, it raises to that exponent. And then we've got mixed here. So here we've got y times y, so y squared, 2 y's. And then we add that to y plus y, which is 2 times y. Okay, so again, repeated addition simplifies to multiplication. Repeated multiplication raises to that exponent. Now there's another way to look at our combining like terms. And here's where we will practice simplifying our expressions. To do this, we are going to start by identifying our like terms. After that, we will add the coefficients of those like terms and write our answers in simplest form. So let's take a look here. Here, I have 3x plus 9 plus 2x plus 5. Well, 3x and 2x have the same variable raised to the same power. They both have the variable of x. So those can be combined. Also, because 9 and 5 are both constants without variables, they also can be combined. Okay, so step 1 is I identified my like terms. My like terms are 3x and 2x. And then my other set of like terms is 9 and 5. So here I'm going to combine. I'm going to add the coefficients of the like terms. So here I'm going to take 3 plus 2, which leads me to 5x. I have 3 x's and I add 2 x's, giving me a total of 5 x's. Here, then I can just combine my constants as well. 9 plus 5 gets me 14. I bring down my plus sign. So my simplified expression is now only 2 terms instead of 4. And it's as low as I can go. Now, this is an x, so this has a variable of x. This has no variables, so I cannot combine these further. This is as simple as it can go. Thinking back to that video about the fast food ordering, these x's are your hamburgers, the constants are your fries. You can't combine them to say 19 hamburger fries. Okay, so they gotta stay separate. I want 5x hamburgers and 14 fries. All right, let's take a look at another example here. Here we've got 8 plus 3z plus z. I like to start with my variables. So here I have 3z and z, and then those can be combined. And then 8's off by itself, so that can't be combined. So I've identified my like terms. Now I'm going to add my coefficients. Now here's where we need to remember, this is super important, that z has a coefficient of 1. So I'm going to add the coefficients 3 plus 1. This 1 is forgotten about often. This has 3 z's. This has 1 z. So we need to include that. 3z plus 1z is 4z, and that 8 has nothing to combine with, so we just bring it down. 8 as a constant and 4z do not have anything in common, so they are simplified as low as we can go. We've got one more to try here together. Let's take a look. Before we start, over here in these 2 examples, I have highlighted my like terms. You don't always have to highlight. If you would prefer to circle or box, or you don't need to do that, or if you want to borrow highlighters, definitely do it. Whatever you need to do to make sure that you acknowledge all of the like terms, making sure that first step is completed. So, for example, we've got 3b plus 5 plus b plus 2 plus b squared. What are my like terms here? Well, 3b and b can be combined. 5 and 2 are both constants, so they also can be combined. B squared cannot be combined with my b and my 3b. B squared is a different variable because it is raised to that second power. So that is not alike with 3b and b. Therefore, it stays by itself. Step 1, I have acknowledged all of my like terms. Step 2, add my coefficients. I've got 3 plus, don't forget that 1. 3 plus 1 is 4 b's. 3 b's plus 1 b is 4 b's. Now I can combine my 5 and my 2, which is 7, and then I can bring down that b squared. That is as simple as it will go. 4b plus 7 plus b squared. I cannot simplify any further, so I am done.